At 3:58 in the morning, the heart arrow motion plant sounded wrong. With the main machining line down, there was no percussion from cutting heads, no carts moving between cells, no operators calling measurements across the floor. Only ventilation hummed above the darkened bays. Nia Porter was half inside the open service panel of the $2 million MX-500 when Rosa Alvarez said, "That's far enough." Nia stopped. A red lockout tag hung from the disconnect beside her shoulder. Rosa's lock was on the box. So was the maintenance supervisor's. The machine had no power, and nobody was giving it any. An orange OEM calibration case sat on a cart beside them, tagged for disposal. "I'm not moving it," Nia said. "I know. I'm reminding you before you get creative." Nia eased the cable carrier toward the position they had marked by hand. On its black sleeve, just behind the rotary housing, a bright rubbed patch caught her flashlight. "There," she said. "Same spot." Rosa leaned closer. "That wasn't there before the shield job." "No. And you think that explains the encoder fault?" "I think it explains why the fault only shows up near one angle." Rosa straightened. "Not the same thing." Nia knew it. 12 engineers and specialists had spent nearly 3 days on the machine and supported the same conclusion: the rotary axis encoder and control package were failing. The machine was 19 years old. By noon, decommissioning was supposed to begin. Nia touched nothing else. If the encoder is dead, why did it give a clean position signal yesterday until the axis got near 47 degrees? Rosa looked at her. "That test was already in the maintenance notes," Nia said. "I didn't invent it. No, you just won't let it go." Footsteps crossed the aisle behind them, not work boots, dress shoes. Rosa turned first. A tall man in a charcoal coat stood outside the taped machine boundary, holding a paper coffee cup. Nia recognized him from the lobby wall. Silas Hart, founder, CEO majority owner. His eyes moved from Rosa to the open panel, then to Nia's intern badge. "What is she doing here?" Rosa stepped toward the cell line. "Locked out inspection only. No energized work." Silas glanced at the disconnect. "At 4 in the morning?" Nia climbed out from beside the machine. Silas looked at her badge again. "You're the intern." "Yes, sir. And this is the machine engineering says is finished?" "They recommended retirement," Rosa said. Silas pulled out his phone. Less than 2 minutes later, Martin Keene's voice came through the speaker. "No further work," Keene said. "Not by the intern. Not until I review this." Nia felt the words land harder than she expected. Rosa took the flashlight from the panel opening. "You heard him?" Silas looked at Nia. "Did you power this machine?" "No." "Defeat a lock?" "No." "Then what exactly are you trying to fix?" Nia looked at the rubbed cable sleeve. "I'm trying to find out why everybody keeps calling the encoder dead when it only dies in one place." On the phone, Keene said, "Mr. Hart, that observation has already been accounted for." Silas did not answer him. He asked Nia one question instead. "If the encoder is dead, what did you see it doing?" By 6:15, Nia's badge stopped opening the manufacturing floor doors. She found out the embarrassing way. The reader flashed red twice while 2 day shift operators waited behind her. "Try it again," one of them said. Nia did. Red. Her phone buzzed before she could step aside. *SS temporarily restricted. Engineering review pending. She moved out of the doorway and let the operators through. 20 minutes later, she was sitting in a small training room with a paper cup of vending machine coffee she had not touched. Her university co-op supervisor was on speakerphone. "Nia, I need you to hear the distinction," Professor Bell said. "Nobody is saying you damaged equipment. Then why am I locked off the floor?" "Because they're reviewing whether you exceeded the scope of your assignment." "I didn't energize anything." "I understand that. The machine was locked out." "I understand that too." Nia pressed her thumb against the rim of the cup. Professor Bell continued, "But if heart arrow motion documents this as a safety judgment issue, I have to review whether your co-op still satisfies the program requirements." That got through. Nia needed the credit. Without it, her graduation moved back a semester. A knock came at the open door. Martin Keene entered carrying a tablet. He was in his early 50s, silver at the temples. The kind of executive who never seemed rushed even when the entire plant was waiting on his decision. He waited until Nia ended the call, then he placed the tablet on the table. "I'm going to make this simple," he said. Nia looked at him. "For the rest of your internship, you move to engineering documentation. No machine floor access. No disciplinary write-up. You finish your hours, your evaluation stays clean, and everyone moves on." Nia almost laughed. "You want me to pretend I didn't see anything?" "No. I want you to understand the difference between an observation and a diagnosis." 12 engineers diagnosed a dead encoder that was still reporting position. Keen's expression tightened slightly. "And that," he said, "is exactly the kind of sentence that worries me." Nia had heard versions of it all semester. Not wrong, not exactly, just too junior to say it with confidence. She pulled up the diagnostic screenshot already attached to the maintenance notes. Clean position values, then a dropout near the same rotary angle. Next to it was the maintenance photo from the night before. The rubbed section of cable sleeve was visible without anyone needing to zoom in. Nothing secret. Nothing she had taken from a restricted system. Keen glanced at the screen. "You've already made this argument." "No. I asked a question. You sent me an email saying nobody should call the encoder dead until they reproduced the dropout dynamically." Nia winced internally. She remembered the email. The technical point still felt right. The tone did not. "I could have written that better, yes. But was I wrong?" Keen picked up the tablet. "At 9, I'm presenting the final failure review. At noon, dismantling begins." He turned toward the door. Nia looked at the red access warning still glowing on her phone. If she took his offer, she kept her credit, kept the reference, kept the door open. Rosa had told her to do exactly that. Nia stood. "I want 10 minutes at the failure review." Keen stopped. "To present what?" "The part of the failure pattern that doesn't fit your conclusion." He studied her for a moment, then nodded once. 10 minutes. Nia exhaled. Keen opened the door. "And Porter?" She looked up. "Once that machine comes apart at noon, this argument is over." At 9 sharp, 12 people were already seated around the failure review table. Nia recognized most of them. Controls engineering, manufacturing engineering, reliability, mechanical. The OEM field representative on video. 2 vendor specialists dialed in from out of state. People with titles she had spent the semester trying not to sound intimidated by. Martin Keen stood at the front beside a screen showing the MX500 failure summary. Silas Hart sat near the end of the table, coat off now, coffee replaced by a legal pad. Nia was given 1 chair. 10 minutes. Keen finished the overview first. Repeated rotary axis reference loss. Intermittent encoder faults. Replacement components discontinued. Retropin estimate exceeds the value of continued recovery. He advanced the slide. Consensus recommendation remains retirement. Nia counted the signatures on the report. 12. Then Keen looked at her. "Miss Porter has asked to present an objection." Every face turned. Nia connected her laptop. For 1 second, she wished she had taken the documentation assignment. Then the diagnostic trace appeared on the screen. "This is from yesterday's low-speed maintenance check," she said. The encoder reports stable position through most of the rotary movement. She highlighted the graph. "Here. Clean signal." Then she moved to the next section. "And here, near 47 degrees, the reference drops." One of the controls engineers leaned forward. "That still fits an intermittent encoder failure." "Yes," Nia said, "it could." Keen glanced at her, perhaps expecting more argument. She continued. "But if the encoder itself is failing internally, I don't understand why the dropout keeps appearing in the same physical region of travel." The OEM representative spoke through the conference speaker. "You're suggesting motion-dependent strain?" "I'm suggesting something changes mechanically at that angle." Nia brought up the maintenance photo. The rubbed section of cable sleeve filled the screen. "This is behind the rotary housing. The wear is recent." A mechanical engineer frowned. "Recent compared to what?" Rosa Alvarez said the sleeve wasn't marked like this before the coolant shield replacement. Keen folded his arms. So your theory is that maintenance installed the shield incorrectly? Nia hesitated. Possibly. That word felt smaller than it had at 4 in the morning. She zoomed in on the image. If the shield is sitting too close to the carrier, rotation could load the cable bundle. That would explain why the signal disappears near the same angle instead of failing randomly. The room changed. Not dramatically, but enough. People stopped looking at Nia and started looking at the screen. One of the vendor engineers said, "Do we have the installation clearance?" Keen answered, "We have the service specification." Silas finally spoke. "Can this be checked without putting the machine into production?" "Yes," Keen said. "Mechanically under lockout, any powered movement would require an approved diagnostic procedure." Silas looked at Nia, "So we can test whether her idea is physically possible." Keen paused. "Yes." That was the first moment Nia felt the floor shift back beneath her. Not because Silas believed her, because for the first time, her question had become testable. An hour later, a qualified maintenance engineer and Rosa measured the shield position while Nia watched from outside the machine boundary. The first reading came back close to the lower clearance limit. Nia felt adrenaline rise. "There," she said quietly. "That's it." Rosa gave her a warning look. "Don't get ahead of the number." A second engineer repeated the measurement. Then a third. Keen entered the bay with the current service specification in hand. Nia waited for someone to say the shield was out of position. Keen checked the measurement. Then he looked at her. "Within tolerance." Nia stared at the page. He turned it so she could see the acceptable range herself. Her number was inside it, not by much, but inside. The wear mark was still there. The encoder dropout was still real. And the simple explanation Nia had walked into the room believing she could prove had just failed its first independent check. Nia read the specification twice. Then a third time. The shield was inside tolerance. Not ideal, not generous, but legal, measurable, and within the service limit. Keen did not smile. That almost made it worse. "This is why we measure before we conclude," he said. Nia looked back at the rub mark on the cable sleeve. "So what made that?" "I don't know. You don't think it matters?" "I think a 19-year-old machine can have wear without that wear being the root cause of a control failure." The answer was annoyingly reasonable. Around them, the maintenance team began clearing measuring tools from the cell. Silas stood several feet away with the reliability manager. He had watched the entire check. Nia could feel him not rescuing her. Keen turned to the lead engineer. "Resume decommission preparation. No energized diagnostic work based on this theory." The lead nodded. That was it. Her 10-minute objection had bought a measurement. The measurement had gone against her. Nia stepped away from the barrier before anyone could see how badly she wanted to argue. Rosa followed. "You okay?" "No." "Good answer." Nia looked at her. "You think I was reaching? I think you saw something real." "That's not what I asked." Rosa crossed her arms. "I think you decided what it meant before you had enough to decide." Nia hated hearing it because it sounded exactly like something Professor Bell would say. She looked through the machine window. "What if the clearance changes during travel?" Rosa's expression hardened. "Nia, I'm asking. You're hunting now. The carrier is rubbing." "Yes." "The fault happens near the same angle." "Yes." "And the shield measurement was in tolerance." Nia stopped. Rosa lowered her voice. "You can be right about two things and still be wrong about the third." Across the bay, Keen was speaking with Silas. Nia could not hear every word, but she caught enough. Intermittent faults. Unsupported alternative. Production risk. Silas asked something. Keen answered, "At this point, I have no engineering basis to reverse the recommendation." Nia looked down. For the first time since 4 that morning, she had to consider that maybe he was right. Maybe 12 engineers had not missed something simple. Maybe she had found ordinary wear on a machine already dying somewhere deeper inside its control system. And maybe she had just made herself look exactly like what Keen had warned about, an intern with one observation and too much confidence. Her phone buzzed, a new email, *subject, MX500 Mechanical Service Review. Nia opened it. The reliability group was expanding the failure review to include the coolant shield replacement, performed 2 weeks earlier. She read the next line. Asterisk, maintenance personnel involved in the prior service will be interviewed before final equipment disposition. Rosa saw Nia's face change. What? Nia turned the screen toward her. Rosa read the message once, then again. Her jaw tightened. They're looking at my crew. Nobody said you did anything wrong. You put the shield into the failure review. I said it might be involved. And now they're going to ask whether we installed it wrong. Nia opened her mouth. Nothing useful came out. Rosa handed the phone back. You wanted them to take your theory seriously. Her voice was not angry. That was worse too. Well, she said, stepping away, now they are. By late morning, Rosa was sitting across from 2 reliability engineers in a glass-walled conference room overlooking the machine floor. Nia could see her through the window, could see the way Rosa kept both hands folded on the table, could see Keane standing at the far end with the service report open in front of him. Nia hated that she had helped put her there. When the door opened, Keane looked out. Porter, come in. Nia entered. Rosa did not look at her. Keane tapped the service report. 2 weeks ago, maintenance removed and reinstalled the coolant shield during a scheduled bearing inspection. Rosa answered before Nia could. Correct. Your crew signed the work complete. Yes, and Ms. Porter's theory is that the shield may be interfering with the cable carrier. Rosa's eyes moved to Nia then, not accusing, waiting. Nia felt the old instinct rise. Defend the theory. Keep the possibility alive. Do not give Keane another reason to call the whole challenge reckless. But the measurement was still intolerance. That mattered. She said it might, Keane continued. If the installation caused the interference, we need to know who performed the final fit check. Rosa's jaw tightened. My crew did. One of the reliability engineers asked, was the clearance verified after installation? Yes. Recorded? No. That check isn't separately logged for this service task. Keane made a note. Nia saw it happen, a missing record, a convenient gap, and suddenly she understood exactly how easy it would be to let the story slide in that direction. Her theory survives. Maintenance takes the risk. She keeps looking smart. Rosa absorbs the damage. No, Nia said. Keane looked up. No what? My theory doesn't support blaming her crew. The room went still. Keane closed the pen in his hand. You raised the service work. I raised the shield because of the rub mark. And maintenance installed the shield. Yes. But the static measurement is within specification. Keane studied her. So you're withdrawing your concern? I'm withdrawing the claim that bad installation explains it. Rosa finally looked directly at her. Nia continued. The wear is real. The angle-specific dropout is real. But I don't have evidence that Rosa's crew caused either one. One reliability engineer said, that weakens your alternative failure explanation. I know. You understand what that means for the retirement recommendation? Yes. Nia heard how small the word sounded. Keane leaned back. This is the first thing you've said today that improves my confidence in your judgment. It should have felt like praise. It did not. Nia looked at Rosa. I'm sorry. Rosa's expression barely changed. For what? For reaching before I knew. Rosa stood. I've got 32 years in this building. One of the engineers started to speak, but she raised a hand. I'm not worried about one interview. I'm worried about getting attached to a theory nobody can prove because somebody higher up needs a reason this machine failed. Nia said, I'm not doing that. I know. That surprised her. Rosa picked up her safety glasses. But I can't keep helping you chase this. Nia felt the words harder than the badge restriction. Rosa, my pension review is next spring. My crew has families. If engineering wants to test something, engineering can test it. She walked to the door, then stopped beside Nia. Being curious is one thing. Her voice was low enough that only Nia heard. Needing to be right can get expensive for everybody around you. Rosa left. Through the conference room glass, Nia watched her cross the floor without looking back. Keane closed the service file. The executive disposition meeting is in 20 minutes. Nia turned. Silas Hart was already entering the engineering suite. Keene gathered his papers. At that meeting, I'm recommending we proceed with decommissioning. Nia looked once more toward the floor. Her original goal had been simple. Prove she saw what 12 engineers missed. Now that goal felt cheap. If she kept fighting, she needed an answer that did not require sacrificing Rosa to make herself look right. The executive disposition meeting started at 11:20. Silas sat at the head of the table this time. Keene stood beside the screen with the failure summary reduced to 4 slides. Nia had no presentation, no new theory, no Rosa beside her. Keene began with the cost of another day offline. He showed the missed production schedule, the actuator housings already being rerouted to a second plant, the overtime required to recover the delay, and the retrofit estimate for the MX-500. Then he showed the failure history, repeated rotary axis reference loss, intermittent encoder faults, obsolete components, no validated root cause outside the control package. Finally, he added the result from that morning. The alternative mechanical installation hypothesis did not survive measurement. Nia looked down at her notebook. The sentence was accurate. Silas asked, "What happens if we keep testing?" Keene answered immediately. "We continue losing production while working around an intermittent positioning fault on a machine that cuts flight-critical components. And if we retire it, we strip usable tooling, move priority work, and place the replacement order today." Silas turned to the reliability manager. "Your recommendation? Retire." The controls lead gave the same answer. Then the OEM representative, still on video, based on the evidence available, yes. Silas looked at Nia. "You disagree?" Every part of her wanted to say yes. Instead, she said, "I don't have enough to tell you they're wrong." Keene's eyes shifted toward her. Nia continued, "But I still don't understand why the dropout repeats near the same physical position." The OEM engineer replied, "Intermittent failures can appear load-dependent. That does not establish an external cause." "I know." Silas tapped his pen once against the table. "Martin, if we approve retirement now, how soon does dismantling start?" "Noon. The contractor is already staged." Silas sat back. For several seconds, nobody spoke. Then he nodded. "Proceed." Nia felt her stomach drop. Keene did not celebrate. He simply turned to the next page. "I'll release the work authorization." That was the round. Not an argument, not a humiliation, a decision. And Keene had won it. As people began leaving, he walked over to Nia and handed her a printed reassignment form. Documentation group. Starting tomorrow. She looked at the first line. Her internship would remain in good standing. Her hours would count. No safety discipline, no notation about the 4 a.m. inspection beyond the internal review. "You can finish the program," Keene said. Nia looked at him. "And if I sign?" "You stop intervening in the MX-500 disposition." He said it without threat. That somehow made the choice harder. "This isn't punishment, Porter. It's an exit." She knew that too. A reasonable one, maybe even a generous one. Keene left the form on the table. Nia packed her laptop. By the time she reached the intern workroom, contractors were already rolling equipment toward the machine bay. She opened her desk drawer and started clearing it. Notebook, calipers, USB cable. A packet of vending machine crackers. Then she saw the orange tag she had pulled from the calibration case weeks earlier while helping inventory old tooling. *Emertary Axis Travel Kit Verkai before disposal. Nia stared at the words. Travel kit, not static clearance. Travel. She closed her eyes. At 4 that morning, the orange case had been sitting beside the machine because maintenance planned to throw it out with the obsolete tooling. She remembered Rosa telling an apprentice what the kit had once been used for. Not home position measurement. Full arc carrier clearance. Nia looked through the glass toward the MX-500. A contractor had just set a tool cart beside it. She had no proof, only one last question. And this time, asking it could cost her the safe way out. Nia found Keene outside the machine bay, signing the decommission work authorization. The contractors were already waiting. She held the reassignment form in one hand and the old orange tag in the other. "I need one more test." Keen looked at the tag. No, you haven't heard it. I've heard 3 versions of this today. This isn't another shield measurement. He capped his pen. Nia, the machine is coming apart. The old OEM travel kit checks carrier clearance through the full rotary arc. Keen's expression changed slightly. Not interest, recognition. That kit is obsolete. It was built for this machine. It was removed from active calibration inventory years ago because the updated service procedure uses static clearance. Correct. Nia held up the tag. And static clearance is what we tested this morning, but the failure only happens during travel. Keen glanced toward the machine. For half a second she thought she had him. Then he shook his head. You still don't have evidence that carrier load is causing the dropout. No, I have a reason to test it. That distinction matters. I know. Silas Hart had approached from behind them. He had heard enough. What would the test involve? Keen answered before Nia could. A controlled rotation with instrumentation. Qualified personnel only. OEM approval. The machine remains out of production. Risk? Manageable if the protocol is accepted. But we lose more time for a theory that has already changed once. Silas looked at Nia. What happens if you're wrong? Keen's eyes stayed on her. Nia understood the question was not only technical. She looked down at the reassignment form. If I take this, my co-op finishes clean. Silas waited. And if I keep pushing after decommissioning has been approved, she said, I'm probably not getting a full-time recommendation. Keen did not contradict her. Nia folded the reassignment form once. Then again, she handed it back. I'm asking for the test anyway. Keen stared at the paper in his hand. You understand I offered you a way out. Yes. You don't know that this kit proves anything. I know. And you're willing to delay dismantling on that, Nia swallowed. I'm willing to put my name on the request. Silas looked at Keen. Is that enough to justify a test? No, Keen said. We need the actual kit, confirmation it's complete, and the OEM engineer has to approve the procedure. Nia looked toward the maintenance cage. That was when she realized she had made the decision before knowing whether the orange case still existed. Her stomach tightened. She found Rosa near the tool crib 10 minutes later. Rosa listened without interrupting. When Nia finished, Rosa looked at her for a long moment. You turned down the reassignment? Yes. Before you knew the kit was still here? Yes. Rosa exhaled through her nose. That was either brave or stupid, probably both. For the first time all day, Rosa almost smiled. Then she reached into her pocket and pulled out a ring of keys. I heard what you said in that conference room. Nia said nothing. You could have kept your theory alive by letting them hang the shield job on us. I wasn't going to do that. I know. Rosa unlocked the maintenance cage. On the bottom shelf, behind 2 obsolete fixture boxes, sat the bright orange case. Its disposal tag was still attached. Nia stared at it. I thought they were throwing it out this morning. They couldn't. Rosa lifted the case onto a cart. Precision tools tagged for disposal sit 30 days before release. Somebody has to verify they're not tied to active equipment first. She snapped the latches open. Foam-lined gauges sat inside. The curved travel clearance tool was still there. So was the old rotary alignment fixture. Nia let out a breath she had not realized she was holding. Rosa pointed at her. This does not mean you're right. I know. Say it like you mean it. I don't know if I'm right. That satisfied her. The OEM field engineer joined by video while Keen reviewed the old procedure. After 15 minutes of argument, questions, and safety conditions, he approved 1 controlled diagnostic cycle. No production cutting, no bypassed interlocks, qualified maintenance and engineering only, instrumented continuity monitoring throughout the rotary movement. Silas gave the final authorization. 1 test, he said. Keen looked at Nia. And if the result doesn't support your theory, dismantling starts immediately. Nia looked through the glass at the MX-500. The machine that 12 engineers had already written off. The machine she had just risked her clean exit to challenge. This time, she had no confident answer waiting, only a test. The test began at 1:17 in the afternoon. By then, the machine bay had been cleared of everyone who did not need to be there. Rosa stood inside the safety perimeter with the maintenance lead. A controls engineer watched the continuity monitor. The OEM field engineer stayed on video, his face filling one corner of a laptop screen. Keane stood at the control station. Silas remained outside the marked boundary. Naya stood beside him, not because she had been pushed out, because she was not authorized to run the machine. The old orange gauge had been fitted exactly where the original service procedure required it, tracing the carrier clearance through the rotary axis, instead of checking only the home position. Keane looked at the controls engineer. Bessman, good. Connector continuity, stable. Keane turned toward the laptop. Ready? The OEM engineer nodded. Begin at 5 degrees per second. Stop on any reference fault or continuity event. Keane started the approved diagnostic cycle. The rotary assembly moved. 10 degrees, 20, 30. Nia watched the carrier more than the display. At 38 degrees, nothing happened. 40. 43. Her heartbeat climbed. Maybe she had been wrong. Maybe the rub mark meant nothing. Maybe she had traded away the safest 10 days of her career for an obsolete tool and a coincidence. 45. The controls engineer leaned closer to his screen. Small resistance change. Keane immediately said, "How small? Not enough to call." 46. The orange travel gauge moved deeper through its arc. Naya saw the cable carrier tighten against the edge of the coolant shield, not a collision. Pressure. Just enough to change the way the bundle sat. Hold, Rosa said. Keane stopped movement. The controls engineer pointed at the monitor. There. A thin spike had appeared. The encoder had not faulted. Keane looked at Nia. This does not prove your control failure. I know. He nodded once. Continue. The axis moved again. 46.5, 46.8. Then the continuity trace broke. For less than a second. The encoder reference vanished at almost the same instant. The machine alarm sounded. Everyone in the bay froze. The controls engineer stared at his display. Reference loss. Nobody spoke. Keane looked at the axis position. 47.1. The same region. Nia felt Rosa look toward her, but she kept her eyes on the machine. Keane raised one hand. Reset nothing. That surprised her. He walked to the laptop. Can we reproduce it without changing anything? The OEM engineer answered immediately. We should. The first run had been a clue. The second would matter more. They returned the axis under the approved recovery procedure. Continuity stabilized. The encoder recovered. Keane ordered another pass. At 47 degrees, the carrier loaded against the shield again. Continuity dropped. Reference fault. Same position, same sequence. The controls engineer exhaled. That's real. Keane did not answer him. He crouched beside the open inspection area, while Rosa pointed to the connector at the bend in the harness. Under the strain, one side of the locking collar shifted almost imperceptibly. Rosa touched nothing until power was isolated again. Then the team locked the machine out. The connector came apart for inspection. Its retention latch was worn and no longer seated fully. Not enough to fail while resting. Enough to open under the wrong combination of travel and cable load. Keane stood with the damaged latch in his gloved hand. The shield still measures intolerance. Nia nodded. Yes, so your installation theory was wrong. Yes. And the carrier contacts still contributed. Yes. He looked toward the screen showing the 2 reproduced failures. A controls engineer said, the encoder itself may be fine. Keane corrected him. Maybe. Then he looked at Nia. One reproduced failure does not return this machine to production. That was his strongest argument, and Nia knew he was right. Silas stepped closer to the boundary. So what does? Keane answered without hesitation. Repair the connector retention and routing. Repeat the diagnostic arc, full homing, warm up, geometry check, then cut a test part and send it through metrology. Silas nodded. Do it. The repair took less than an hour. The validation took much longer. The first full rotary pass completed without a dropout, then another, then 10. The machine homed normally. Warm-up completed. Geometry stayed inside limits. Near sunset, the MX-500 finally cut metal again. Nobody cheered. A test housing came off the fixture and went directly to metrology. Nia waited beside Rosa while the dimensions were checked. One measurement, then another, then the bore position. The metrology technician looked up. Inside tolerance. Silas turned toward Keene. Keene stared at the report for several seconds. Then he removed the decommission authorization from the clipboard. I'm withdrawing the retirement recommendation pending return to service approval. He looked at Nia, not warmly, not defensively, professionally. The encoder was not the root failure. The sentence landed harder than praise would have. Silas gave 3 instructions. Cancel dismantling. Restore Nia's technical floor access. Reopen the failure review around the interaction between the prior service change, cable routing, and connector retention. Then he looked at Keene. No one closes this by saying an intern got lucky. Keene's eyes moved to the repeated test results. They won't have to. Rosa stood beside Nia as the MX500 completed another clean cycle. At 4 that morning, Nia had been asking permission to question a machine. 12 engineers had already declared dead. Now the machine had answered for her, but one question remained. What happened next to the intern who had just forced the company to reverse a $2 million decision? The MX500 did not go straight back into full production. For the next 48 hours, it ran under restricted release while the OEM field engineer and Hart Aeromotion's metrology team repeated the validation sequence. No reference loss, no continuity break, no unexplained alarms. By the 3rd morning, the machine was cutting actuator housings again. Nia watched the first production batch from behind the yellow floor line. Her badge worked now. That small green light meant more to her than she expected. Rosa came up beside her, carrying 2 coffees. Don't make this emotional, she said, handing one over. Nia smiled. Wouldn't dream of it. The internal failure review took 3 more weeks. It did not conclude that 12 engineers were incompetent. It concluded that the investigation had become anchored on the encoder and control package after repeated reference faults. The recent mechanical service had been treated as unrelated because every static clearance measurement remained inside specification. Nobody had tested what happened to the cable carrier through the full rotary arc. The worn connector latch had turned that missed interaction into an intermittent electrical failure. Rosa's crew was cleared of the unsupported installation error concern. Martin Keene remained vice president of manufacturing engineering. He was not fired. He did, however, receive a corrective management review for approving retirement before the failure could be reproduced under controlled conditions. He also had to lead a change to the equipment disposition process. From then on, any recommendation to retire high-value machinery required a cross-discipline review of recent service changes and, when it could be done safely, an attempt to reproduce the fault before dismantling began. Nia completed her co-op on schedule. Her final evaluation did not call her a genius. She was grateful for that. It described her as technically persistent, occasionally too quick to form conclusions, and willing to correct herself when the evidence changed. She thought that sounded fair. 2 months later, after graduation, Hart Aeromotion offered her an entry-level position in mechatronics engineering. Not a management job, not an executive office. A desk, a toolbox, a starting salary, and people who expected her to prove what she said. She accepted. On her first week back, Rosa found her in the tool crib with the bright orange calibration case open on the counter. You stealing my antiques now? Nia looked up. Putting it back into active inventory. Rosa leaned against the doorway. You know what I remember about that whole mess? Nia expected something about the machine. Rosa surprised her. That meeting. What meeting? The one where you could saved your theory by letting them blame my crew. Nia closed the case. I was wrong. That's not the point. Rosa tapped the lid. You were scared you were wrong. There's a difference. Nia thought about that. About the red badge reader. The reassignment form. The moment she had folded it and handed it back without knowing whether the orange case was even still in the building. She picked up the old disposal tag. For weeks it had read, Asterisk, verify before disposal. Nia removed it. Then she filled out a normal calibration label and wrote the next inspection date. Nothing dramatic. No trophy. No signature from Silas Hart. She placed the case back between the other precision tools. Out on the floor, the MX500 started another cycle. The sound carried through the tool crib exactly like every other machine in the plant. And that was the part Nia liked most. The $2 million machine 12 engineers had called dead was no longer a miracle. It was just working.